To another session in this school knowledge Daily prize, and I trust that all our students are getting the best knowledge, and I'm so grateful for your responses that you are sending in. And trust me, your responses or the response to your answers are on their way, and they will get to you shortly. In our last class, we were talking about carbohydrates, and I explained explicitly what carbohydrates entails. Look at the whole topic of carbohydrates, and that is the link on your screen. I will encourage you to go back and attend that class. And all our videos have packages for all our students who follow suit to the end. So if you follow suit to the end, please, I will need your response to that. I will need your response to that email. When you send in your response, I will respond back to you as soon as I receive it. So that was that about carbohydrates in our last class. I will encourage everyone to go back and attend the class. But today we're talking about another interesting topic, that is lipids. Today we're talking about fats and oils in summary. And when we're talking about carbohydrates, I make mention of the fact that excess carbohydrates are being stored up as lipids. So today we're talking about the topic lipids, and I will encourage all my students to grab their pens and get their jotters, because they'll be learning something so interesting and they will need to apply it in any sphere or area of their life wherein the knowledge is needed. So to begin with, lipids are organic compounds which are made up of carbon, hydrogen, oxygen, sometimes sulfur and phosphorus, as opposed to carbohydrates which are made up of just carbon, hydrogen and oxygen. And now the next thing is lipids exist as fats and oils. Now there is a misconception, because most people think fat is the same like oils and oils is the same like fats. But trust me, there is a difference between fats and oil. Just follow keen with this lesson, and in the course of the lesson, I will bring out the difference between fats and oil. So in summary, what you think of about lipids is that one, they exist as fats and oils, or fats or oils, and the next thing is that they're made up of carbon, hydrogen, and oxygen, and sometimes sulfur and phosphorus. And one thing also you have to think of about lipids is that they are insoluble in water. Their solubility in water is 0. They are insoluble in water. Now the next one I'm going to talk about is the functions of lipids. Now the first thing is that they are the storage form of energy in the body. Now when we consume carbohydrates, which is being metabolized, is being converted to glucose in the body, and that glucose cannot be stored as glucose. Why? When glucose is stored up as glucose in the body, it's going to raise blood sugar level or blood glucose level. And once blood glucose level is elevated above a certain mark, the body begins to suffer. You start noticing that the nerves gets destroyed, especially the optic nerves, which leads to blur vision and other side effects that happens, maybe polydipsia, polyphagia, polyuria, that occurs as a side effect of that increased amount of glucose in blood. So excess glucose is not stored up as glucose, but rather it is stored up as fatty acids and glycerol. In summary, it is stored up as lipids. So lipids is a storage form of energy in the body. Now the next function of lipids is that they are the structural components of bowel membrane. Now if you go back to our lecture when I was talking about introduction to biochemistry and the cell membrane, I made mention of the fact that the cell membrane is a lipid bilayer bed. Molecules which are not lipid soluble, how do they gain entrance to the cell? I made mention of the fact that lipids in the level of the cell membrane exist as phospholipids and glycolipids, and I explained explicitly their role and how they aid in the transfer of substances into and out of the cell. So one function of lipids is that they are the structural components of bowel membrane, in the sense that they aid in the structure, they aid in the movement of substances into and out of the cell, maintaining cell integrity and cell fluidity. Now the next thing is that they act as metabolic regulators. Now let's go back to the first function, which I said they are the storage form of energy in the body. That is, energy is stored up as fatty acids and glycerol. Now when the concentration of fatty acids and glycerol is enormous in the body, it becomes an endocrine gland. Or fatty acids and glycerol have the ability to become an endocrine gland. Now we'll talk about the ability of becoming an endocrine gland. We are talking about the possibility of them secreting hormones. Let's take for example the hormone leptin, which is secreted by fat in the adipose tissues, which goes to the hypothalamus of the brain, reducing or increasing the feeling of fullness, and also increasing expenditure of energy. That's why I notice that there are certain times which you become too full and you just feel like, oh, I need to burn some calories, I need to lose some weight. Now, lipids have the potentiality of acting as metabolic regulators, as I explained earlier, the ability to secrete hormones which regulate the functions of the body. Now, the next function of lipids is that they provide insulation against changes in temperature. Now, you notice that those who have, for people who are bulbous in size, you notice that the amount of heat they tend to feel is lower than those who are skinny. That is because the fat in their blood acts as a cushion, reducing the intensity or acting as a blanket, preventing adverse low temperatures. Now, the next function of lipids is that they give shapes and contours to the body. Now, let's take for example in women, when you notice that some women have curves and some women have big breasts, and now that is just the presence of cholesterol, which is a lipid, which is concentrated in those areas, giving the shape and the size of certain parts of the body. So that is that about the functions of lipids. The next thing we're talking about is the classification of lipids. So lipids are classified into three categories. You have simple lipids, you have compound lipids, and you have derived lipids. Now, simple lipids, these are esters of fatty acids with glycerols. And examples of simple lipids, we have fats and oils. Now, the next thing we'll look at is compound lipids. They are fatty acids esterified. These are esters of fatty acids with alcohol, as opposed to simple lipids which have glycerol instead. Compound lipids are esterified with alcohol in addition with other compounds. For example, phospholipids, which contains phosphoric acid as an additional compound, while derived lipids are lipids which are derived from other lipids. For example, fatty acids, which are derived from other lipids. So in summary, simple lipids are esters of fatty acid with glycerol. Compound lipids are esters of fatty acids with alcohol. So take note of that difference. While derived lipids, from its name, they are lipids which are derived from or gotten from other molecules. Examples of examples of simple lipids include fats and oils. Examples of compound lipids include phospholipids, where examples of derived lipids include fatty acids. Please take note. Now, the next thing we're talking about in details, fatty acids. Now, fatty acids, the fatty acids are produced from the conversion of carbohydrates, and this is the most form of lipids in the body. Now, they are produced from the metabolism of carbohydrates. I explained earlier when we talk about the function of lipids. Excess carbohydrates in the body is not stored up as glucose, rather it is stored up as fatty acids. Reason why it is categorized as a derived lipid. So, and the next thing you have to note is that it has the carboxylic group. Reason why it's an acid due to the presence of the carboxylic group, and it is an aliphatic hydrocarbon, meaning it lacks the presence of a benzene ring. So what you take note of about fatty acids, that one, they are derived lipids, that is, they are got from carbohydrates. Two, is the most common lipids present in the body. Three, it's an aliphatic carboxylic acid, that is, it lacks the presence of benzene ring. Four is it has the carboxylic group. Now, the next thing we're talking about are the clinical applications of fatty acids. Now, the first thing I'm thinking of is that excessive fatty acid leads to obesity. Now, we're talking about obesity. Obesity, we're looking at the measurement of weight, of height over obesity, we're looking at the body mass index, and we'll be looking at the adverse effects of obesity has much more to do than just the body size. Obesity goes right far or goes up to the extent of affecting even heart health. Now, I'll talk about abnormalities in cholesterol and lipid and lipoprotein metabolism will lead to dyslipidemia. Now, what you have to take note of is that these fatty acids, abnormality or abnormal increase in this fatty acid also can lead to a condition called dyslipidemia. Now, dyslipidemia is not a disease, but actually it's a condition which is progressing into a disease. Like, for example, patients who have diabetes who have abnormal fat level or abnormal lipids level are in this will be categorized in the state of dyslipidemia. Now, dyslipidemia is not a disease, but it is progressing into another disease. For example, atherosclerosis, which is one of the major risk factors in dyslipidemia. In poorly managed diabetes, metabolism of fatty acids and lipoproteins are deranged, leading to ketosis. Now, for diabetes that is poorly managed, there will be the breakdown of ketone bodies. Now, talking about poorly managed diabetes, that we're looking at the absence of glucose in the body, and which the body start breaking down fats. The absence of glucose in the body leads to the body breaking down fats and is going to lead to the presence of ketone bodies. And this can be noticed in those who undergo prolonged fasting and those who are in a condition of poorly managed diabetes, and it can be noticed from their birth because ketone bodies are gases which are released through the nostrils. So that is what you have to take note of about the clinical applications of fatty acid. One, excess deposit of fat can lead to obesity. Now, fat which can be demonstrated in cholesterol, when it's abnormally high, it leads to a state called dyslipidemia, and this dyslipidemia is not a disease, it's a condition progressing into a disease like atherosclerosis. Now, without much ado, we'll be looking at the next type of fatty acids, saturated fatty acid. Now, saturated fatty acids are fatty acids which have just the carbon to carbon single bond. There is the absence of the double bond. And now these saturated fatty acids are solid at room temperature, so they are commonly called fats. Now, what I've made mention of the fact that there's a difference between fats and oils. Now, we're talking about fats, we are talking about lipids which are solid at room temperature. We'll talk about oils, we'll talk about lipids which are liquid at room temperatures. And now, one adverse effects of saturated fatty acids is that they raise low density lipoprotein cholesterol levels. Now, what you have to take note of about low density lipoprotein cholesterol is that these are molecules which carries lipids from the liver to the body. So when this concentration of LDL cholesterol or bad cholesterol is increased beyond normal, the body tends to suffer. So, example, one major disease that is attributed to this is atherosclerosis. So, increased saturated fatty acids in the body is going to lead to increased level of LDL cholesterol or bad cholesterol. The next thing we're talking about is unsaturated fatty acids. Unsaturated fatty acids, unlike saturated, have the presence of double bonds and they are liquid at room temperature, or they are also called oils. Now, one thing we have to take note of about unsaturated fatty acids is that they increase the concentration of HDL cholesterol or high density lipoprotein cholesterol. Now, these molecules aid in the transportation of lipids from the body to the liver, wherein it is broken down, detoxified, and sent out of the body, and the one which is needed to be reabsorbed is done so depending on the need of the body at that particular time. They have a lower melting point as compared to saturated fatty acid. Now, all naturally occurring fatty acid exhibit cis isomerism, not trans isomerism. Now, unsaturated fatty acid exhibit cis isomerism. Now, we'll talk about cis isomerism. We're looking at the presence of identical or similar groups on the same side. That is for cis isomerism. Trans isomerism is the presence of similar or identical groups on opposite sides. So, as I said earlier, unsaturated fatty acid, what it does, the first thing it does is that it lowers LDL cholesterol, it lowers the level of triglycerides. Now, understand that when triglycerides level goes high above normal, there is a high probability of that individual developing a condition called hypertriglyceridemia. Now, and in that condition, there is high probability of the nerves. The first is that the nerves get damaged, and this can be seen in a condition where a patient, this can be seen mostly in the case of diabetes, where the patient is progressing into atherosclerosis, passing through a condition called dyslipidemia. Now, one benefit of unsaturated fatty acid is that they aid in the absorption of fat-soluble vitamins. Unsaturated fatty acids, one thing it does that it increases, as I said earlier, it increases the concentration of HDL cholesterol and lowers LDL cholesterol. So in summary, it increases good cholesterol and reduces bad cholesterol. The next type of fatty acid we'll be looking at is the we're talking about the polyunsaturated fatty acid. Now, these are fatty acids which contains more than one carbon to carbon double bond in their hydrocarbon chain. Now, they contain more than one double bond. Now, I'm talking about unsaturated. We're looking at the probability of the hydrocarbon contain just a single double bond. Now, I'm talking about polyunsaturated. It contains more than one double bond, and the benefits of polyunsaturated fatty acid in the body is similar to that of unsaturated fatty acid, as it reduces the concentration of LDL cholesterol and triglycerides, boosting up the concentration of HDL cholesterol, keeping the body healthy and preventing adverse risks. Now, the next thing is that they are liquid at room temperature. They are also oils, as opposed to saturated fatty acids, which are fat or hard fat at room temperature. Now, the next thing is that they are beneficial for heart and brain health. They aid in the maintenance of membrane fluidity and integrity. If you have to know more about membrane fluidity and integrity, I'll encourage you to go back to our previous lessons on the introduction to biochemistry, when I was talking about the cell membrane, and I explained that explicitly. I'll encourage you to go back and watch it. And if you are not subscribed to our page, I don't know what you are waiting for, because there is so much knowledge that you are receiving, and this knowledge is so summarized that you don't need to stress yourself again. I encourage you to subscribe to our page and refer this page to others. As I said earlier, the benefits of polyunsaturated fatty acid is similar to that of saturated fatty acid. The next thing is that they are highly reactive. As I said earlier, they are liquids at room temperature. Now, the next type of fatty acid we look at is trans fatty acid. Now, it's a type of unsaturated fatty acid where at least one of the double bonds is in the trans configuration instead of the cis. Now, I explained earlier that I was talking about this unsaturated fatty acid, that most of the fatty acids are in the cis form rather than the trans form. Now, I'll talk about the cis form, or the cis isomerism is the presence of identical or similar groups on the same side. But we'll talk about trans isomerism is the presence of similar or identical groups on opposite sides. Now, trans fatty acids fall under that category. So trans fatty acid is to tell you that this type of fatty acid exhibits trans isomerism, as opposed to other fatty acids like polyunsaturated, saturated, and unsaturated, which exhibits the cis isomerism. Now, one thing that clinical implication of trans fatty acid, that it also increases LDL cholesterol, similar to the saturated fatty acid. As I explained earlier, LDL, low density lipoprotein cholesterol, carries cholesterol or lipids from the liver to the body, putting the body at risk of adverse health condition. Now, trans fatty acids, likewise saturated fatty acids, can be found in dairy products, can be found in meat or beef, and in ruminant animals. Reason why, when your cholesterol level is very high, you are being advised to regulate your dietary intake of these foodstuffs, such as to keep your health in check and such as to prevent adverse conditions. Now, the next type of fats or lipids we are going to talk about is the triglycerides. And now, for laboratory science students, you mostly hear about lipid profile. Now, we'll talk about lipid profile. We are talking about the measuring of the different lipids in the body. Now, we'll talk about the different lipids. We'll be looking at low density lipoprotein cholesterol, high density lipoprotein cholesterol, total cholesterol, and triglycerides. Now, those four factors make up the lipid profile. And now, a patient patient is being classified as being in the state of dyslipidemia when either of these parameters have value beyond the normal range, and all of them has adverse effects. Now for triglyceride, what you have to think of about triglyceride is that first of all, these are naturally occurring fats and oil. Now they are as similar to other lipids, they are insoluble in water. Now excess triglycerides in the body can lead to increased levels of LDL cholesterol. Now, as I've been explaining earlier, LDL cholesterol places the body at risk. An increased amount of triglycerides can lead to pancreatitis, and it can also lead to obesity. And now triglycerides can be gotten from, or increased amount of triglycerides, or this type of fatty acid can be present in dairy products, meat, beef, and other ruminant animal. Reasons why you have to ensure that the intake of this is at its minimum, so that you don't expose yourself to those health risks. Now, the next thing you have to think of is that lipids or fatty acids and glycerols are stored in the adipose tissues. Now, as I explained earlier, the difference between fats and oils is that fats are solid at room temperature, while oils are liquid at room temperature. Now, the next step of lipids we talked about is the phospholipid, and the phospholipid is a compound lipid which talks about the esterification of fatty acids with alcohol and other elements, and the phospholipid is the lipid molecule with phosphoric acid. And now this phospholipid is very important when we talk about the movement of substances into and out of the cell membrane, because according to the model of hypothesis at the level of the cell membrane, it states that the cell membrane is composed of a phospholipid bilayer with hydrophilic heads outside and hydrophobic tails inside, which maintains a stable aqueous environment. I've explained that already in the lesson talking about the cell membrane. So to know more about phospholipids, I'll encourage you to go back and attend that class. So we have come to the end of our lesson on lipids, and as our tradition entails, there is a package for everyone who has followed suit to the end, and I will encourage you to respond with your answers as soon as possible. Don't forget to like, don't forget to share, don't forget to subscribe, and also don't forget to recommend this page to someone. And don't forget to follow us on all our social media platforms, being Facebook, be it TikTok, and be it YouTube. Thank you so much. Yes.